new way of teaching computer use agents to reason. I will explain everything step by step, but first let me summarize. So let's say you have a model that's using your computer and you tell it close this window and make this text bold. So the large language model will look at your screen, take a screenshot, and then look at your task instructions, and it will output, for example, coordinates on your screen of the button that needs to be clicked. And then that button will automatically be clicked based on the coordinates. So that's how you have large language model controlling your screen, your graphic user interface, based on your instructions. This paper found out a better way to let that large language model think and reason about your instructions before executing them. Before previously, there was not too much focus on the instructions themselves. Previously, papers were focusing on just looking at the instructions and then where to find it on the screen, and that's it. They didn't focus on looking at your text instructions and then thinking about your instructions on how to do it, what to do there. So this paper has two-stage training to improve exactly that, to make the model be able to reason and think about your instructions. In the first stage, it will just teach it the format or few different types of reasoning it can do. For example, it can reason about the appearance, like what does the button look like based on your instructions? What kind of button does it need to find? What is the function of the button, or what is the function you want it to do? And where it is on the screen, where it could be, and what's your goal with it. And so once it learns this format of how to reason, in the second stage, it will just learn which reasoning type is best for which kind of task. So in the second stage, it's learning to select the best type of reasoning. It can also mix them up. So second stage is not constrained to just these four types of reasoning. It can do whatever reasoning it wants, mix them up. The first stage is just about teaching it how to reason, different types, and the second stage is about letting it choose and learn the best type of reasoning and mixture of reasoning types for each task. So let's now understand this all step by step. First of all, authors find that existing datasets that are for training AI to use computers, to use graphic user interface, have flawed instructions. 23% of the data has flawed instructions in the data that they looked at. And also using different types of instructions, like describing an icon's appearance versus its function, can dramatically improve performance by up to 76% if you do it well. To improve upon these findings, they propose that the model generates its own instructions. They call it instruction as reasoning. And so it's gonna use its generation of its own instructions as a reasoning process. And this framework consists of two steps, two parts: supervised fine-tuning, where we teach the model to generate diverse reasoning pathways that are different instruction types that it generates. And then improving that reasoning with reinforcement learning that we will talk about, how it's done. Previous methods just focused on the screen, the vision of the model, and action, how it's gonna click, but they treated these instructions that humans give as just given, and they weren't concerned with thinking about or improving the instructions themselves. But different humans would give totally different instructions. Like if they want to close a window, they can say, click the red X, click the button to close the file manager, get rid of this screen, etc. So the model will mainly understand what it learned from training data, but when it sees some other type of instructions during inference, it may get confused. So there are four types of instructions: appearance, describing the appearance of the icon; functionality, what the icon does or what needs to be done; location; and intent, I want to close this window. And every type of instruction works best for some type of task. This shows that there was a massive untapped potential in leveraging the type of instructions. And besides that, they also found that 23% of the dataset contained either ambiguous instructions, mismatch because these instructions were describing something completely different than what was shown in the data. that showed how to follow those instructions. And so when they cleaned this data, the model improved. And this is their new method. So user input can be make important points stand out, and model will have internal reasoning or thinking. I will analyze this form. To make the text stand out, I need to click the B button to make it bold. And so model's output is coordinates of the bold button. Their training pipeline starts with data generation. So they take the clean dataset, and use GPT 4.1 to rephrase instructions, generate more types of instructions, like based on appearance, functionality, location, intent. So they will just augment instructions, create different types of instructions as well. And in the first stage, they will just train it to reason and to generate output. So they will choose randomly one of the instruction types in the first supervised fine-tuning. Here, goal is not necessarily to produce the best reasoning, but just to learn the format of how to reason. So it needs to output these think tags, and inside it's gonna use one of those four types it's randomly chosen. And then in the stage 2, it will learn to select the optimal reasoning, the best type of instruction as reasoning. And most importantly, in the stage 2, reinforcement learning, it's not constrained to just one of these four types. It can mix them, it can select one. The idea here is to just ask the same question multiple times, and it's gonna always pick either some of the reasoning methods that it learned, or it's gonna mix them up. So here we just check and compare the answers and reward the answers that gave correct answer. The reasoning paths that gave the correct answer. So now the model will just learn to reason. In the supervised fine-tuning, we thought it 4 different types of reasoning just to kind of give it a start. And then it's gonna combine everything. It's gonna come up with its own reasoning in the stage 2. That's gonna be it for the next video. Join my school to become AI researcher, link below, and see you in the next video.